In the previous video, I demoed the star rating component and presented the algorithm used in its implementation. But as I believe some people may have not understood why I created an algorithm in first place, I want to dedicate some time to explain how an algorithm can help us set our course of action straight. So the first thing that you need to learn or know about this algorithm is that this is an abstraction, meaning I'm hiding the implementation details. So for example, when I say display initial scale, you can see that I'm not specifying how to do that, and this means that the same algorithm can be used with a different language, library, or in summary a different technology. And other benefit of creating an algorithm is that it helps you to put in a logical order the steps that you know you are required to take for achieving a goal. So in my case, I want to implement a star rating component, and I have to specify the steps, but not to identify the steps, but of course I need to take these steps in a logical order, right? Then you also should know that an algorithm is combined. You should combine the algorithm with the knowledge of the technology you want to work with. So for example, in the context of React, when I say, or when anyone sees display something, you know that you will have to create a component for rendering a piece of UI, and then we have some different events here: mouse enter, on mouse enter, on mouse leave, on click events. We need to save the rating. So in the context of React, we know that we need to work with state. So this is why I created an algorithm. It helps us think in advance. It helps us identify and order the steps that we need to take to achieve our goal, and when we combine the algorithm with the knowledge of the library, language, framework of the technology we will be using, then we can know what we need to do in this context, right? In the context of the technology that we choose to work with. Now let's implement the component, and I need to define a path. Let me call it star rating, and then a page. This is going to be my test page. Let me export default function star rating test page, and then return a div, and inside this div I want a paragraph. The paragraph will have the text of rate me. Let me increase the font size and change the color. Let me center everything using Flexbox. And change the background color. Now, so I'm defining a path here, and if I have a page, this path will become a route in Next.js. So we can visit now this star rating, and this is what we get. Let me reset the zoom, and then implement. Okay, look at the algorithm, and we need to display the initial scale. For that, let me add the star rating component. This is a client component. We need to work with a React hook and events. Let's import use state from React and then export default function star rating. We want this component to be a reusable component, and because of that we want to destructure the props object and access the desired number of stars, but if no number of stars is specified, we want a default number of 5. And then let me create an array of white stars initially. Again, I'm going to use these Unicode characters, the white star Unicode character. Let me copy this. White stars array equals to array based on the number of stars, and then I want to map and simply return a bunch of white stars. Let's add a piece of state as the initial scale. And then render this, right? So return UL display flags to put them in a row, and then here we want to loop this array of stars and display them. We know that each item is any star. We have access to the star and to the index of the star, and here we want to render an ally. Inside of the ally and span, let's set the key to the index, and then inside of the span we want to render the star. If I save and visit the page, nothing happens because I have created the component, but I'm not using the component yet, so I have to import the star rating component and then render some in here. Let's start by defining this first scale with a, let's add a first scale with 3 stars, and then a second scale with no without defining the number of stars, which means this is going to default to 5, and then another with 10 stars. Let's save and check the result. Okay, so we need to add some CSS. First, as you can see, when I hover over the scale, the pointer changes. I will add some CSS to prevent this. This is happening again because these are Unicode characters, right? Let's add some style, inline style this time, no tailwind class, and change the font size to be 48, the color to be yellow, and the cursor to be the default cursor. Let's check the result, and this is what we get. Okay, back to the algorithm. We have to Okay, we are displaying the initial scale. Now we have to check, has the mouse entered? Has the mouse left? And has the user clicked? So we know that we are going to call functions when these events happen. So let's add the event listeners here on mouse enter, on mouse leave, on, let's follow the order, right? We have on mouse enter and then on mouse click, on click, not on mouse click. Okay, so here let's define some functions and then we can finish their implementation later. Handle mouse enter, function handle click, function handle mouse leave, right? Let's see something here. So when go back to the algorithm, don't worry about this error here right now. This is going to be fixed. So we display the initial scale and then we listen for the on mouse enter event. When this happens, we update the scale, and to do that we should call the handle mouse enter passing the score, right? Here we need to accept the score, which is of type number. And then on click we are going to call handle click, and on mouse leave, handle mouse leave. Okay, we should see no errors. Right, so why am I incrementing the index before using it as an argument? Because when the user hovers over the star here, if we send the index, we would send 0, but we know that this is 1 point, right? This is the equivalent of choosing 1 point, 2 points, 3 points. That's why I'm incrementing the index. And then here we will use this information to update the scale, but we should not do it directly. We should not update the state directly. So let's create a temporary piece of state, array, number of stars, and then here we want to map, and we are going to do something here. So okay, if you do not understand what's happening here, with this syntax we create an empty array. It has a length of defined by the number of stars, but only the slots are available. There is no item. So let me call this slot. I'm not going to use it anyway. And then we have the index. To indicate that this is not being used, we add an underscore. And what do we want to do here? We want to loop over this array of empty slots and create a new array where we check the index to see if the index is less than the score, and then we return for this position a black star. and otherwise we push into the array a white star. So again, this syntax here, this line of code is the equivalent of doing that, of doing this const empty equals array, and then we would loop const s, not s, field, because now s is field, right? We map, let me copy this, over the empty array, and then we fill it, right? So we create an empty array, and then we fill we create a new array based on the empty array, but filling it according to the logic defined in the map function. Let me get rid of this, and then we need to set the scale to s. So display initial scale. Has the mouse entered? If so, then update the scale. If not, keep displaying the initial scale, right? Right now, if we visit the application, you can see that as I'm not hovering over the scale, I keep displaying the initial scale, but when I hover over the scale is updated. Okay? Let's check the next step. And if the user clicks, then we have to save the rating. And of course, we have to identify when the user has clicked. Why? Because then when the user visits the application, right? If he clicks, we want to save the rating, and we need a flag for identifying that the user has already rated, because when the mouse leaves the scale, we can use this information to display the rating or to display the initial scale. So let's add two new pieces of state. Const rating and set rating equals to use state. I'm going to use the generic syntax to specify that this is an array of string. This is going to receive an array of string. Okay, if I hover over the state, as you can see now, it receives an array of strings, it accepts an array of string, and then another piece of state, const user has rated and set user has rated. And initially, of course, this is going to be false. Go back to the algorithm. Okay, we are at this point. We update the scale and check. Has the user clicked? If yes, we save the rating, which means to save the current state of the scale, right? So we save the current state of the scale, and this state becomes the rating. Let's do that. On click, we call set rating and pass as an argument the current state of the scale, and then we set an user has rated to true. So here you may think that this is going to be called several times, but as you can see, this when the function is called again, the state will be already set to true, and then React will identify that the state has not changed, and therefore this is not going to run to cause a re-rendering of the component. Okay, so effectively this is not going to cause a re-rendering, but if you want to prevent the function of being called at all, you could add something like that. If the user has not rated, okay, you can use this thing here, but it's not really necessary. Or use a if statement, or use the logical end. Okay, it's not really necessary, because again, when React calls these the use state, the set function, then it will identify that the state has not changed, and it will not cause a re-rendering. Okay, so back to the algorithm. Scale has been updated. Has the user clicked? If yes, save the rating. We are already doing that. But if the user has not clicked, we have to check, has the mouse left? In case negative, we want to keep updating the scale, and this is already working, right? We can click and we can still update the scale, but when the user leaves, if the user has not clicked, we want to display the initial scale. So let's go to the mouse leave, and then we need to check if the user has rated. Then we want to set the scale to the rating, right? When the mouse leave, but if the user has not rated, then we want to set the scale to its initial state. Think I have a mistake here, but let me check. Yeah, I forgot to destructure. Remember that this is an array. This one doesn't, I don't need to do that because this is the correct shape already. Okay, it's working as expected, so you can see that when I hover, it's updated. When the mouse leaves, then the scale is reset to the initial state, but when I click, then the rating is set, right? And then now, so user has clicked, yes, save the rating, and then we have to check if the mouse does not leave, keep updating the scale. So let me refresh the page. I click, but the mouse does not leave the scale. I keep updating the scale, and when the mouse leaves, then we display the rating, right? Mouse user has clicked, save the rating. Has the mouse left? No, keep updating the scale. If the mouse leaves the scale, then display the rating. At this point, the mouse can enter the scale again. So if we hover the scale again, right, what do we want to do? We want to update the scale, and then if the user clicks, selects a different score, then we update the rating. So it's working, right? And then if the user does not click, we check, has the mouse left? If yes, then we update, we display the current rating, and if not, we update the scale. Okay, so user clicks here, mouse leaves, display the rating. If the user clicks again and keep hovering, I changed the rating here, but I'm still hovering over the scale, then we want the scale to be updated, right? And then when we leave, when the mouse leaves, we display the updated rating. So this is how you can use an algorithm to help you implement your component. And this is how you can implement a star rating component using Unicode characters.